I choose pretty easy task for today. I think mock interview should be as easy as it can be to train, but not too nervous much, as we're nervous on the real interview. Many of the beginners are scared about this interview, but I think the point is practice. Practice is our main helper that helps us to overcome this fear, to feel ourselves better about interviews. More tasks you complete, better you can do it in the real interview. We can go, I think, to the diagram space and see the task. Why not? So let's try this link. I think it should works. Oh, I see arrows with names. That's great. So it works, and it's not so slowly. That was a few days ago when we did mock interview. I can describe in short this task. So it is pretty basic task that we can start our interview. URL shortener. So let's imagine that we are making a startup in about 15 years ago. It was the time of web growing fast, and there are many links that are pretty long and unreadable, and we think that we can make URL shortener or tiny URL that will help us, that will be used hardly by customers. So there are some requirements. I will tell requirements and will answer it. So I made requirements. As we know, let's train on this task. There are some always functional requirement and non-functional requirement. Can someone take requirements from here and make functional, maybe square, and non-functional? Rewrite these 8 requirements in functional and non-functional. For example, I have one square with functional requirement, and I have second square with non-functional requirement, and we should figure out what are of these requirements functional and unfunctional. Anyone just can make a functional non-functional requirement in square. So let it be here functional requirements, and here will be non-functional requirements. So the basic idea is that functional requirements are such requirements that we can how we can communicate with user, what we can see, and non-functional requirements can help us to deal with some traffic and big loads. Yes, first one, we can we have long URL, we go to the service, and expecting to receive short URL. So there are 1 and 2. Yes, and 3 about system service behavior that link will expire. For service should be highly available. Yes, fault tolerance can have redundancy or be highly available. There are all of the non-functional requirements, as well as URL generation should be fast. URLs not predictable. What about 7 and 8? Yes, it is our requirements. Small.
The small should be under functional.
Maybe, yeah, it is arguable. It can be. It can be in functional, I suppose, yeah. But not so quite sure here.
From a feature point of view, it would probably go in non-functional. It's not a feature that it is small.
It's not a feature, yeah.
What original require? Oh yeah.
So we can stop here. I think we made a great job. The next step, so it is a first step in every interview. What do you think about second step? What should we do? What should we clarify to make our system?
Calculations.
Yeah, good point. Capacity planning, like what is the traffic that we're expecting?
Yeah, some numbers. So interviewer should ask the person who makes interview some numbers about what you can ask. For example,
Like
first thing would be the number of URLs that are going to be written to a service. Second would be the write. Sorry, first would be the write traffic, the number of new URLs coming in to be written per second. Second would be the read.
Yeah, can you write it down?
Oh, sorry.
It would be better for all of us to see
Yes.
your questions here, I think. So, really great short list of numbers we should clarify. Let's say I will answer that there is 8 RPS on write. So, I mean, rate of short URL generation. It is about first. What about read? I can give you rate that we have this ratio about read-write. Read-write ratio. So for every write, for every URL generation, 100 read requests. About short URL expiration policy, I would say that every URL time to live 5 years. Now, based on these numbers, you can calculate something else.
Yes.
Now we have requests per second, and we can make requests per day and maybe per month, per year.
This is okay. This is wrong. But this is just for the
What about without kilobytes right now? Just estimate for 5 years as you start to make. So in 5 years, overall, we have this number of writes of
Yes.
URL generation requests, and we will have this total amount of requests in 5 years. So I suggest calculate it without kilobytes right now. And can you calculate it?
$46 billion, I think.
So we're waiting for
46 billion.
someone to calculate overall numbers of generations in 5 years.
46 billion.
Hmm?
46 billion.
Can you write it down, please? So in 5 years we have 46 billion URLs. So it is not only short URL but long URL and something, maybe some more metadata as well.
This is just for this is the number of URL generations in 5 years.
Yeah, so it leads us to calculate some storage space. I suggest to show what kind of data should be in the storage. Short
The
URLs.
model. You mean the database model, right?
So
Yeah, I think the high level data that we'll try to store, right? The long URL.
yeah,
the
the
URL.
entity of the storage, what it will be was.
So maybe a mapping of short and long URL.
Can you write it down here in the square I prepared for it? So we have short URL as string, then what have you mentioned?
Yeah, the short. This one is a short URL. This will be the shortened postfix and the shortened ID, basically just the ID, not the entire URL. We'll have the ID, the long URL, right? Apart from that,
so some idea of our row if we're talking about SQL database, for example. Then short URL, then long URL. What do we have to store more?
Maybe create a timestamp.
Yeah, that's great.
created items one, yes.
Created timestamp. So that is our entity. You wrote it down about estimation. I can make it bold for about storage estimation. So we have data, we have number 46 billions of such entities. So we should know the size of each entity. What kind of size it would be? What kind of estimation can you propose here? ID is some primary key, so we even would mention it. So short URL. We
So
want.
the short URL is going to be like, I mean, it depends. Let's say we have 6 characters, so that is 6 bytes. Long URL will consider 100 characters, so that is 100 bytes. Created timestamp is what? int long.
I think the long URL will be like close to 2000. Like, so that's the max.
3000 characters.
Yeah, that's the max size of URL. Especially you mentioned, right? Like there are like a lot of session data and other things that gets
Yes.
passed, like a query string parameter. So that can get really long. 200 is kind of small.
Okay.
Yeah, we should go for the bigger size. Yeah, short URL could be 6 bytes, but like it depends on the algorithm that you're trying to choose, right? Like can 6 bytes can support like 46 billion URLs, right? Like can it provide uniqueness, right? So
So that is more of calculation. So normally
right,
what
that's right.
happens is
So
that we have
yeah,
So I think the biggest number here is 2000 bytes,
right.
but should we really think that every URL would be 2000 bytes?
Right. It's not an efficient solution, but
on average it would probably be 100 or 200 bytes. You can take something like 110 bytes per row on average.
Yeah, there are some numbers like maximum of possible values or average or median
Yes.
or
Let's not waste much time on this. Let's go on the service, I guess. Estimation is, I guess, 1 to 2 minutes is more than enough. Like, as I think.
you can write it down, your proposal.
Can we all participate in this, or is it like the guy who's speaking is can only participate?
Whatever you want.
Okay.
Once I solved not I'm directly, but candidate solved, and he suggests to make some median for estimation. For example, 20 bytes in median.
So I think that the max size will be like 2000 bytes or whatever, but if we do the overall estimation, we will assume that what is the average size of the row multiplied by the total number of rows, right? So if we take the average size to be 200.
So
Right.
let's
So-
make a final suggestion about long URL. Just write it down and we will move forward.
Okay. Fine. So we have this, right? ID is, so we have 210 bytes into 46 billion. That is what?
So that's great. Now we have about row estimation about data entity. So we can say that we have about 20 bytes for data entity, and now we have entity quantity 48 billions. So you can now write it down what kind of storage volume we need.
Nine 9.6 TB, 10 TB.
Can you write it down, please? So that is really great. Now we have we see a read-write ratio. We know how many URLs in our volume in 5 years. What kind of storage volume do we should have? Maybe something else, or we will finish with this.
I would have thought of storing the TTL as well, but I think that is not part of the. Do we have user-defined TTLs? If yes, then we would have had to store that as well. Otherwise, it's fine. I mean, as far as the data model is concerned.
You say about URL expiration.
Yeah.
Yeah, we will make some service for it, I think, a bit later.
Yes. Yes.
We can now go to the next. What do you think we should do next? Any variants, maybe?
Next is the high level, the overall design.
So the first suggestion, high level design. Any more ideas? I think we can make some AP as well.
We can make?
So yeah, let's make some API. We will see how our service will communicate with customer. Anyone can draw our service in just square or circle, really high level thing, and draw customer with some arrows and with some pretty simple API. So, for example, we have our URL shortener.
So we have a shorten API which will have just the URL, I guess, for now. because we are not providing anything else. Um, and then we have a simple read where we give the short URL ID and it's just two APIs, I think.
You can write down your proposal about API.
Okay. Mhm. We have two APIs only. Uh, we are not doing anything else. Um, yes.
So
Requirement
that's
1 and requirement 2 are the only ones API-able.
that's great. We have first scenario. Sorry, I should accept our spectator. So shortener, yeah. We have first arrow. It is first scenario. Give long URL. Receive short URL. We can write it down in some functional way, like function call shorten, like you started to write down. Or we can make it more RESTly. Just for simplicity,
Got it.
let's continue your suggestion.
I think REST uh, form of API would be better.
Yeah,
Very
we can
generic.
make REST. Can you make it? That's great. So we provide our short URL.
Yes, this would be like what? 2 / URL. Whatever is our 6-digit ID. That's it.
So looks great.
abc.com/12345 6.
I think it will be enough. The basic idea is here. So we made our API. And what do you think should we do next?
Now comes the actual assembly, I think.
Can you repeat, please?
Now comes the actual design
Yeah,
after
maybe propose something.
actual like the design itself.
Where are you?
Okay, so let's say a client comes to our website and he is trying to Um, so, so first we are going through the creation flow, and then we will go through the data flow.
Wonderful.
Um,
Yeah.
so
Great.
we have a short range of service, and this is our database, which is fine. Uh, we'll also have a then this goes here to the lead balancer and back to the client that the URL is now. So we return the shortened URL to the client.
Are you asking a question or connecting? Sorry.
I'm just sort of thinking out loud. Basically.
Right.
Uh, then we go through the read flow, which would be so we go to the load balancer and it goes to the short join service again, right?
Mhm.
From there, it will go to the cache service to get the actual URL first. If it is not found, then we will have the right. I mean, this is basically right through. So we go to the database, we get the URL from the DB, right? We store it in the cache. There is one more thing. This will not go to cache. This will be stored in. There is this networking component. I am forgetting. Uh, so firstly, we will get redirected when we return from here. So the client receives a 302 redirection with the new URL, right?
Right.
Uh, but it has to be stored somewhere else. This is not going to go in just a cache. This will be cached
So
in the
the 302 URL,
API gateway.
I believe the 302 is an kind of like a DNS entry, I believe.
That yeah, 302 is the permanent redirect. That is fine. I'm talking about where will this be stored? This is not. I mean, this won't just simply go to the cache server. This will be cached in the API gateway level or something. It doesn't even need to go like beyond the load balancer slash API gateway.
No,
Uh,
so you pull that through an API, right? So it has to go through the load balance, not the load balancer, the API gateway, right?
from the API gateway itself, it should return. It should
Should
be
be able to
cached at the
talk
API
to the
gateway layer or something.
And what kind of
Uh,
cache system you're implementing here?
so this is a so it's a simple. I mean, we can use something like memcached as well since the usage is pretty small and memcached is faster than Redis in that scenario. This is we can distribute it or we can
Yeah, I think cache aside is good. More like what kind of like when do we
no
update the
because
cache?
cache.
Yeah, when do you update the cache and all this stuff?
Yeah, I was thinking the cache. I mean, not cache aside, but right through. So
Right.
both. Okay, no, this is not right through. Sorry, yes, this is not right through. This is cache aside.
Right.
Correct. That is right. As far as the cache is concerned, we can have a distributed system wherein when the sharding is done on the basis of the ID, which we don't need because the overall size is pretty low. So just replication, I mean, just having read replicas for the cache should do. Though ideally speaking, we can do sharding as well, right?
Right.
Uh, but the amount of data is what?
Very minimum.
So let's say we have 20%, 2080 thing, right? We know the volume rule. 20% of this would be what? Uh,
2
okay,
terabytes.
we will still have sharding and so on, which is fine. So firstly, we will have there will be two things. One, the cache is going to be sharded, right? The sharding will be done on the basis of the short ID generated for the URL, right? Uh, then this will also be replicated. There will be read replicas of this as well. It is not just one instance. Uh, the propagation from primary to secondaries would be synchronous because it is cache, so it is going to be fast, so that is fine. Um, so we have distributed cache with read replicas. Same goes for our databases, the exact same scenario. The database we can use is probably MongoDB because it is, or made for horizontal scalability needs. Plus, we do not have any joins or any sort of transaction required either, and it is horizontally scalable. Easier to scale in comparison to yes, what do you call it? RDBMS family. So there is that. Then we have the key generation service, which should have gone. So coming to the key generation service,
I think
we have to.
Vladimir wants to focus on your option for choosing the MongoDB, I believe. Like, right?
Um, I just write down this conversation that has happened. Yeah, that is great that there were mention about choice, about SQL based database that mostly a seed system and NoSQL. We don't need here some asset transactions. We do not build a financial system that where it is crucial. Uh, it is
Yes,
enough for us eventual consistency that MongoDB provides and scaling as
yes,
well.
I've used MongoDB
yeah,
and actually DynamoDB. Personally, I like DynamoDB for this one. It's just like a key value pair kind of thing. So
Mm.
just my take on this one. Just
Yeah, by the way, it is pretty
can
key
we
value
compare?
task that entity.
Can we compare the two? Do you know the differences, performance difference, or like in any way how are Dynamo and
it's
Mongo
like
different?
the
I
data
know that it is key value,
key
so that
value,
is the
right?
only
Like
thing
our
I.
system is more like a key value, right?
Yeah.
Right. Like you're passing the ID and you want the long URL, the short URL, right? So it's just like a
Right.
right. It's more suited for this than MongoDB. It's more if you have like large JSON objects kind of thing, then storing that and pulling data from that. I would go MongoDB.
Okay.
And there are like plenty
Are
of
there any performance differences? I'll let you know.
um, definitely key
I
value
haven't
pair is
worked on
faster, right?
Dynamo. So.
Right. Yeah, key value pair is definitely faster, right? So
Okay.
I think MongoDB won't be bad for this one, but I think DynamoDB is more ideal for this one
Okay.
because it's like a hash table, right? So the database is like also a
Yes.
hash table. Your data is also like a hash table. So it's my take would be DynamoDB here.
Okay. Fine. Um.
And general, I still wasn't. I mean, like your voice goes down at times. So how are you? When
Okay.
are you updating the cache? Like,
So the cache is updated. So the flow is that when something comes for read, right? It goes through the load balancer and goes to the service.
right,
Now, for a read request, it goes to the cache first
right,
to get the actual
okay,
um, URL.
hmm,
When there is a cache miss, right, then it goes to the database, gets it, and writes it into the cache,
okay,
and then returns it. So that is when cache is updated.
right,
Uh, There is a problem of thundering herd, and I'm not sure how to solve it because we cannot know in advance what fraction of the URLs will be the most searched. We can probably have analytics and so on, I guess.
Hmm.
We can have an analytics service which,
I think that might be an overkill for this design,
yeah,
right? I think at 10 terabytes is nothing, right? Um,
true. Oh,
like
sorry.
it's
Yeah.
I can have the entire thing in the cache service, like Twitter, right? Like
Yes.
they run the whole thing on cache. So
Yeah.
10 terabytes is nothing. I would put everything in Redis cache and uh,
And just
also have a,
replicate it. True.
yeah, just yeah,
Yes.
exactly. So and Redis handles the replication. You don't have to even like worry about
Yeah.
so
Just having read replicas would do. That's
right,
true.
right. That
And by the way, we can use this ratio, which is pretty general, that 20% of all requests
right, right.
make 8% of loads. So, for example, for this service, most recent generated URLs will make great read loads because no one wants to some old URLs. That is how we can calculate cache size. For example, we have 10 terabytes per
Right.
5 year, and we have cache for about last 20% or percents of them.
Yes, so around 8, uh, not 8, I mean, yeah, nearly 10 TB of cache would have the entire data in cache. We cannot drop it because we have to have persistence in case the cache goes down. That is there. But yeah, even services like Redis do provide persistence, but that can still not be like 40 TB, like whatever we have, I think. For persistence, we should have the cache always backed by database. So,
And there is another estimation that we should work even if cache is down. For example, so
yes.
cache will help us to make some faster, but we should live without it.
Yes, that can happen, but the service would slow down somewhat.
Yes.
Right.
So guys, it was about 1 hour that we um, made this system. It is pretty great. So we have what do we have left? I think the last thing.
I think the critical thing, the algorithm, right? Like how are you generating the IDs, right?
This,
And
the
how do you
ID,
make sure they're
yes.
not predictable and those kind of things.
That's right.
Really close.
Yeah. So we can explore something later by ourselves, and so the system will be complete for all of us. I think for this moment we can finish. We made a great job, all of us.
Thanks, Valadin.
Right.
Yeah,
Thanks for
Thank- Thanks,
uh,
everyone, actually.
yeah. I think in chat we can continue. And by the way, Scarlett wrote to me that he forgot about today interview, and
Okay.
yeah, he apologized and ask for schedule it for tomorrow, but I don't quite sure for tomorrow, but I think we can do it, and we'll see his design
Yeah.
But we should
So,
should not tell him about the task itself, that it is URL shortener.
yeah. So, Vladimir, Nick here. I also wanted to give the interview, but I wanted in a time bound window, like 45 to 50 minutes, and each area time bounded way, so that at least everything should be covered. Correct?
Uh, do you want to know about task,
Not today.
or it is random?
No, not today. Whenever you have time.
Yeah, about task, we should um, define the task beforehand, or it should be random for you.
Okay. Okay.
Or random exam.
No, random. I would go for the random. I'm preparing right now.
Oh.
I'm working as a senior TPM right now, but I'm preparing onto the system design. So yeah,
I'm
definitely.
also prepping. I would like to like give
Yeah, I think
mock
one thing
interview.
is like getting familiarized with these tools would really, like help.
Yeah.
To, it's okay to take in charge and like continuously go this is how I'm going to do this. These are the requirements. Next time
Correct.
we go that rather that'll be more like the interview based,
That's correct.
right? Yeah, time bounded. We could have done this whole thing in an hour, right? So
Yeah, it should be actually.
right,
In YouTube, a lot of such kind of interviews are already there where they will showcase that, okay, hey, these are like 10 minutes you should use for your requirement layouts, right?
right.
Then for capacity calculation. So these are the like 3 or 4 steps you should follow it. So I prepared like that way, but the only thing is now I need to present and get the
Yes,
confidence.
sure. Yeah, I think this is a great platform for that, because
Yeah, exactly.
a lot of friendly folks and giving great feedback.
Exactly. At least they'll get from everyone. And then again, prepare and then give again.
Right.
Maybe
Yeah,
three or
yeah,
four times,
sure.
give you more confidence.
Yeah, that's
So we
important.
can
Okay.
direct message to with ourselves about future mock interviews.
Okay. Okay. Thank you. Thank
So
you very much.
that's great.
I'll do that. Yeah, definitely.
Thank you.
Thank
Thank
you.
you, Ladin.
Yeah, thank you.
Okay. Thank you
Thank you.
guys, everyone. Good night and bye.
Thanks again.